So in this video we are going to cover the full SQS message queue in microservice production level client. So we will see like introduction to the message queue and AWS SQS fundamentals and why we need to use this SQS and the types and real world implementation in an online school management system and the development story and the production best practices for this and some common interview questions, like those things we will cover. So messaging queue, we know this. So it's a form of asynchronous service to service communication used in microservice architecture. Messages are stored in queue until they are processed and deleted. So each message is processed only once by single consumer. So this is the actual process. Producer will producer service sends the message to queue, and consumer service receives and process the message from queue. And queue means the temporary storage for messages, and messages like unit of data sent between services, and dead letter queue for message that could not processed. And what is AWS SQS? So it is a fully managed messaging queue service that enables you decouple and scale microservices, distributed system and serverless applications. So this is the SQS message lifecycle. So send message and receive message, process, delete. So consumer only deletes the message after successful processing, and visibility timeout. So message becomes invisible after being received. So default is 30 seconds. Why SQS in microservice? So we know to handle the service communication, failure handling, load management and data consistency, we use this. And the SQL's types and use cases. So we have a type called standard queue and FIFO queue, first in first out queue. So in the standard queue we have a throughput like nearly unlimited message per seconds, at least once delivery. Message may be delivered more than once. Best ordering, messages may arrive out of order. High throughput scenarios where duplicates are acceptable. And FIFO queue, so it is like up to 3000 messages per second with batching, 3000 per API, exactly once processing. So message is delivered exactly once, and ordering, message processed in exact the same order. And use cases, financial transactions, order processing, like those things. Let me repeat. So this is standard queue, it's unlimited message. FIFO we have up to 3000 message. So message may delivered more than once, but here message deliver exactly once. So best ordering, or message may arrive out of order, but here ordering will be same exact order that was sent. And there is an online school management system. For example, we take this. Our school management system consists of multiple microservices. So we have user service, course, enrollment. So it handles the managed student enrollments and notification, payment service, process the payments and the transactions. Analytics service tracks and analyzes the user behaviors, and assignment service like manages the assignments and submissions. So this is the diagram. So user service enrollment and payment service uses the SQS, post messages, and notification and analytics assignment use this queue and utilize that, process the messages one by one. So scenario 1, there is a student enrollment flow. We have user service, so manages the students, teachers, and admins. So this case 1, when a student enrolls in a course, that means course service. So multiple actions need to happen. So create a enrollment record, send confirmation email, and update analytics, and process the payment and grant course access. So these things need to be done. So without SQS, there it will be a tightly coupled. All services must be available. With the SQS, we can decouple the services work independently. So enroll student, we create the enrollment and publish the event to SQS. So student enrolled, that means like a student created, we are publishing the message, and notification service consumes it and process it. So it will consumes that and send confirmation email. So it is getting from our our queue system. It's getting from our queue system and it will process and then sends the confirmation. Same way in different services happens. So it will gets the payment and it will go for analytics with those way. And another one use case, there is a assignment submission. So student must submit the assignments that need to be and stored securely, checked for plagiarism and graded, notification to teacher, updated in gradebook. So similar way it will use this with FIFO queue. And dead letter queue for failed payments. So payment processing can fail due to various reasons. We need to handle retries and eventually move to dead letter queue. So process payment, we are doing process payment on that. In the catch block it's getting exception. So after, if there is any exception happen, so we have to move to DLQ. So how messages moved to DLQ? We will see step by step flow. Automatic DLQ movement mechanism. So when creating a queue, you configure it that specifies dead letter queue, the ARN of DLQ, and maximum received count, maximum number of times the message can be received before moving to DLQ. And this is the flow. Message was in queue, consumer receives it, approximate receiving count 1. So visibility timeout starts at the time once message received. So message becomes invisible. So once the visibility timeout started, message become invisible. Processing, in case of processing failure, exception thrown, message not deleted at the time. And then visibility timeout will expire, message becomes visible again. So means what? There is a message, it receives it and visibility time started. That means visibility timeout starts, message become invisible in the queue, and then we are processing. We have to process that within 30 seconds. For example, once we receive it, in 30 seconds something, it will become invisible. So then processing, in case in middle of the time, if processing once if it is success, we have to delete it. So during the time, once it is success, we have to delete it, so it won't be there in visibility. Even visibility expires, so it won't be there because we have deleted it. So in case if it is failed, we won't delete the message in consumer side. So what happens? So visibility timeout expires, message becomes visible again here. So consumer receives the message again. So approximate received count now 2. And then processing fails again. Processing fails again. So repeat until approximate count maximum count. So here what will happen? Repeat. So this will if we set up to 3, maximum received count 3. So until that it will process the message again and again. So then what later happen? SQS automatically moves the message to DLQ. Okay, got it. So now here key points: approximate receive count. SQS tracks how many times the message has been received, not processed successfully. And visibility timeout. If a message is not deleted within that time, so it becomes visible again. Automatic movement. SQS automatically moves to DLQ. So approximate receive count exists maximum count. So no manual invention. So you don't need to manually move the message to DLQ. So it happens automatically. To be more clear, here if you see queue configuration, when we are creating queue, you configure the retry policy that specifies dead letter queue target. So the ARN of DLQ and maximum receive count, maximum number of time message can be received before moving to DLQ. So now maximum message processing flow, 2 scenarios. So first case, the process success. So if the we are passing the queue message and consumer calls the receive message received, and visibility timeout starts immediately. Message becomes invisible. Once received, it will starts immediately, message becomes invisible, and processing starts in our consumer service. And process success, later what we will do, consumer calls this delete message. So this message will deleted permanently in our queue. So message is gone from queue. Visibility timeout expiration does not matter. So even visibility timeout expires or nothing matter here. So it will permanently will be deleted. And failure, we have seen that already. So once it is failed, after timeout expires, the message becomes visible again, and it will calls the receive message and process approximate count 2. Once the maximum count reached, the approximate receive count maximum reached, SQS automatically move to DLQ. So when visibility timeout starts, it starts immediately. So when receive message is called successfully, let's see SQL types and use cases. So the standard queue, we have seen, and FIFO queue we have seen, and creating AWS SQS queue based on the type. Like there is a few configuration, so things to consider before creating SQS queue. And queue type selection. So standard queue used for high throughput scenarios where duplicates are acceptable. And FIFO, first in first out queue use when ordering like exactly once processing or critical, those time we can use. And dead letter queue planning, so always create a dead letter queue first. We need it's a ARN for retry policy. So decided on maximum receive count, so typically we can set 3 to 5. So set longer retention period for DLQ 14 days it is recommended. And visibility timeout, set 2 to 3x your average processing time. So if our notification service might take 30 seconds, we can increase that the processing visibility timeout processing to up to 1 minute 2 minutes like that. So if we set too short, it will be risk of duplicate processing. If we set off too long, it will be failed messages take longer to retry, so there will be a delay on that. And then message retention period, standard retention period 4 to 14 days, it is usual default. And then DLQ we can keep it for 14 days for investigation. And long polling, so enable to reduce the API calls and cost. Recommended 20 seconds. Receive message, wait time seconds, long polling. And then we have security and access. We can set IAM roles policies for producers and consumer, and encryption at the REST, SSE, KMS like that, and VPC endpoints for private access. And we can set naming conversions, cost consideration, standard queue on cost and FIFO queue will be on cost. And long polling reduce the API cost saving option. Security is critical for SQS, especially when handling sensitive data like payment information, student record, personal. So this section covers 3 fundamental security aspects. So one is IAM roles and policies. So this is important because of principle of least privilege. Services should only have access to what they need and prevent unauthorized access. Unauthorized services or users cannot read or write messages. And audit trail, IAM policies provide clear audit logs of who accessed what. And compliance, so required for HIPAA and PCI DSS. Cost control prevents accidental or malicious message flooding. So IAM policies are a security guard checking IDs. Only services with the right ID card IAM role can access your queue. So without proper IAM, anyone with AWS credential could read your messages. So this is the IAM policy structure. So action, we allow to send message, receive message, delete message, and get queue attributions. Producer policy, send message, get queue URL, only that. And consumer policy, receive message, delete message, get queue attributes, and change message visibility. So there are two types of IAM policies for SQS. One is identity-based policies and then resource-based policies. Identity-based policies attached to IAM user or roles. It is most common, attached to the services application that needs access, and attached to EC2 instance roles, Lambda function role, and used for producers and consumers. Resource-based policies we have attached to SQS queue for cross-account access. Attached directly to SQS queue defines who can access the queue and used for cross-account access or specified access control. Identity-based producer policy, first one. So it allows service role to send message to queue, allows getting queue URL and attributes needed to send message, and cannot receive or delete messages. So here action like send message, get queue URL, and get queue attributes. So allows the options or VSTN. So so this policy is just a structure, and this one specifies the ARN. Replace your queue ARN. So here ARN explanation, expand Amazon resource name. So it's just a resource name. So enrollment service needs to send enrollment events, and payment service needs to send payment notifications. Any services that publishes message. So to create that in our IAM console services IAM and roles, left sidebar we have policies, then create IAM role. It is recommended approach. Create a role and select trusted entity type, choose the AWS service, select the services type, and attach the policy. Create policy and attach whatever it has, and replace the with your resources. So we can review and we can create that, and then we have to attach the policy to role. Encryption at rest. Why it is important? So message encrypted even if someone gains physical access to storage. So encrypted data useless without the key. So encryption at rest means messages are stored in encryption format. Even if someone steals the hard drive where the messages are stored, they cannot read them without the encryption key, and it's like storing your valuable in a safe. Even if someone breaks in, they need to combination of like key and the message. How it works? Message send. When you send message, SQS encrypts it using KMS key and stores encrypted message in SQS. Once message received, when received, SQS decrypts it automatically. Your application doesn't need to handle this encryption or decryption. So encryption types, we have AWS managed keys. It is free, automated key rotation and no key management overhead. Customer managed keys, so recommended for production, full control over the key policies, cross-account access support, detailed audit logs we will have. So this is the process to create SQS manually in IIS. Step 1, create dead letter queue. So you need to the dead letter queues here and to configure the main queues retry policy. So in SQS services, click create queue and configure the DLQ. 14 days retention, visibility time of 30 seconds, and receives message wait time 0 seconds. And access policy optional, and encryption, enable server side encryption. Choose encryption key AWS managed or KMS, and click create queue, and then copy the ARN Amazon resource name. We need to use that in our project. And then click new queue. So on that we have to click create queue, choose the queue type standard or FIFO, and basic configuration, queue name, those things, and configuration settings, visibility, timeout, message retention, delivery, those things, and DLQ enabled. Maximum receives 3. After 3 failed data, it will be moved to DLQ. And encryption, access policy, those things we can give, and we will create queue. And verify configuration, check the queue details, queue URL, queue ARN, approximate number of messages, and test. We need to test the queue, send them a test message, receive the message, and verify it. Production best practices for SQS. So naming conversions, use the descriptive names, include environments, and FIFO queues. Queue separation, separate queue for different event types, priorities, and consumers. Message design, so message structure should be like this: type, version, timestamp, correlation ID mandatory, and data and metadata, the source of the service, like those things. And best practice, keep messages smaller, use JSON, include correlation ID for tracing, version your message schema, include timestamps. And retry strategy, so process message with retry async. If retry is greater than maximum retry, move to DLQ. And performance optimization for long polling, reduce the API calls and cost. So and then we should have security. We have to keep IAM policies and encryption, and then monitoring and alerting. So we can use CloudWatch metrics to monitor and alerts if the queue depth greater than the threshold, and the dead letter message count greater than 0, so indicates the processing failures. and some common interview questions and answers relevant to SQS. How do you handle message ordering in distributed system? So we use FIFO where ordering is critical, payment processing, assignment submission, like those things we use FIFO. We use message groups to enable parallel processing while maintaining the order within the each group. For example, assignments for different courses can be processed in parallel, but assignments for the same course are processed sequentially. For high throughput scenarios where the ordering is not critical, notification analytics, we use standard queue and handle this redundancy application pool. So how do you prevent duplicate message? We use FIFO queue, and redundancy keys include the unique key identifiers, and the database constraints we use the unique constraints. So what happens when consumer fails while processing the message? So SQS has visibility timeout mechanism, and if fails it will be moved to DLQ. If the consumer process and deletes the message within this time, it will be done. If it's anything crosses, if that will be, if timeout will over, then it will appear again. Then consumers picks up and retry. So once the maximum race counts reached, it will be moved to dead letter queue. And how did you exactly message get moved to DLQ? Explain the mechanism. So that's what we have configured the dead letter queue, target ARN, and then message maximum receive count. So that's also we have configured. So once it's reached, this will be automatically moved to DLQ.